Good day, class. So in our last lesson, we looked at how we could use algebra. Specifically, we looked at the method of elimination to solve a linear system. This is the same linear system that we looked at in example 1 of that video. The method I want to show you now uses even more algebra in order to find that point of intersection, and this method is called substitution. So what you do first is isolate either x or y and from either equation. This means you have 4 choices. 1, 2, 3, 4 choices for your starting point. Now I'm going to show you this method using fractions. If you hate what you see when I'm using fractions, you can use decimals. But if you're going to use decimals, you have to be careful. You cannot round, never, not once in the whole problem. So you'll want to make sure that you isolate something that has a coefficient of 2 or 5, because dividing by these numbers will give you beautiful decimals. Dividing by 7 will give you a mess. Dividing by 6 would give you repeated decimals, which are hard to work with. So if you're going to use decimals, I'd like to caution you, you can't round at any point. You'll want to be dividing by numbers like 2, 4, 8, 5 would be nice, 10 would be nice. Okay, but as I said, I'll use fractions. So I'm going to start with the lower equation, equation 2 right here, and I'm going to choose to isolate x. So how do I do that? Well, first I would isolate 2x like this. 2x is going to be 9 minus 5y, or you could write negative 5y plus 9. Okay, either of those would be fine. So then what is x equal to? X is found by dividing by 2. So we will write negative 5 over 2y and positive 9 over 2, just like this. Okay, so if you were doing decimals, this would say negative 2.5y plus 4.5. Okay, we've now used up that second equation. So we're going to take this expression for x and substitute it into the first equation. So into the other equation where the x is. So right here in this first equation, we're putting this binomial. So that's going to look like this. We'll need a bracket. 7 times negative 5 halves y plus 9 halves plus 6y is 20. Okay, so since we used equation 2 to get the expression for x, we substitute that into equation 1 where the x is. Okay, and now we're just going to solve. You can see there's only y in the equation here. So the first thing is to open up this bracket using multiplication. So that will be negative 35 over 2y plus 63 over 2 plus 6y is 20. Now notice at this point, 2 terms contain y and 2 do not. So we collect like terms. So the 2 terms containing y are going to stay on the left side of the equation. So this is negative 35 over 2y and positive 6y. On the right side of the equation, we already have 20. So this term is going to come to the right side. And look, I'm going to have to subtract it. Okay, so now we've got it written. This is when we collected like terms. All right, so this is the only part where really we have to worry about the fractions. So what we want to do is figure out how many y's we have here and how many y's we have here. So we have negative 35 over 2 plus 6. So you might know that that's the same as negative 35 over 2 plus 12 over 2. So you can get a common denominator, and then that'll give you negative 23 over 2. If you don't want to do that, you can use the fraction button on your calculator here. So you would type negative 35 over 2, see what it looks like, plus 6 equals, and you get this is the mixed fraction, or hit shift and hit the button again, and see, you do get negative 23 over 2. So that's what we would write here, negative 23 over 2y equals. And you can do the very same thing to work out the number on the right. Just punch in 20 minus 63 halves. Okay, so 20 minus 63 over 2 equals, that's the mixed fraction. Hit shift, hit the button again, and look what you have, negative 23 over 2. Okay, so how is y determined at this point? By division. You'd be dividing negative 23 over 2 by negative 23 over 2, and you would get y is equal to 1. Okay? All right, here, if you don't want to use your fraction button, remember you would do, 20 over 1 is the same as 40 over 2. So we have 40 over 2 minus 63 over 2, and that, of course, is negative 23 over 2. Okay, once we have y determined, the easiest thing to do to figure out x is to substitute. You can substitute into this equation, or even this one right here where we've already got x isolated. This is the one I would normally use with this method. But as I said, if you prefer, you can put y equals 1 here or here. So I'm going to go to this one right here. So where the y is, we're substituting 1. So x is negative 5 halves times 1 plus 9 halves. So negative 5 halves times 1, of course, is negative 5 halves. So now we have negative 5 halves plus 9 halves, which is 4 halves or 2. Okay, and let me just show you, we could have just punched this in to the calculator just like it is as well. So you could have just done negative 5 over 2 times 1 plus 9 over 2 is 2. So that corresponds. Okay, and at that point you have your answer. You have x equals 2 and y equals 1. So you would have your point of intersection like this. All right, so how does this method work? Once again, choose any of the 4 variables. Isolate. So we isolated x from equation 2. Equation 2 is now used up. So this expression 4x has to go in equation 1. So always into the other equation. So we substituted it right where the x was. Open up the brackets using multiplication. Collect like terms to solve. Once you have one variable determined, you can simply substitute its value in order to find the other variable. Notice we write x before y. Okay, I'm going to do another equation, another example, but you know, my pen was failing here. I think you can see. So I'm going to go grab another pen first. I've obviously been doing way too much mathematics if all my pens are dying. Okay, let's try a second one. Oh, I should point out, of course, that in the last lesson, we solved that very same system using elimination. So you can check that out, of course. You've already watched that video, I imagine. But you can see, look, we got the very same answer, of course, using elimination. Okay, let's do the example number 2 from last day. And now we'll use substitution. So this was 4x minus 5y is negative 34. And 2x minus 3y is negative 22. So you do have your choice. You can isolate this x, this y, or this y. I would caution you, I would not suggest that you isolate something preceded by a negative sign. It's just one step harder. You might make a mistake. So that means we'll isolate one of these two x values since they are preceded by positive signs, okay? So we could isolate this x or this x. To do things differently than the last example, I'm going to isolate this x right here, okay? So from the first equation, we're going to isolate x just to show you how many options you have. So first, you isolate 4x. When this goes to the other side, it's positive 5y. So 4x is positive 5y minus 34, like that. This stays negative, of course, because it's already on the right side of the equation. So only one term moves, and it has a different sign in front of it. You could write negative 34 plus 5y. If you like that better, negative 34 plus 5y is the same. Okay, now we're supposed to divide these terms by 4, right? So it's like this, but we don't really like it trapped like that. So I have to split it. So it's going to be 5 over 4 y minus, now here it's 34 over 4. And you could leave it 34 over 4 if you want. It'll make no difference in the math here. Or you can reduce it to 17 over 2. Okay, so 34 over 4 or 17 over 2. And now we have used up equation 1. We have an expression for x. So we'll be substituting the binomial right here, where the x is in the other equation. 2 times, we need a big bracket because we're putting in a binomial. So 5 quarters y minus 17 halves. Okay, like that. So where x was, we put in this binomial. And now the steps should just be logical, okay? Because when you look at this, hopefully you can see, oh, I better get rid of the bracket by multiplying in like this. Okay, so what will you get? You will get 10 over 4. And you could leave it 10 over 4y, or you can make it 5 over 2y. Minus. Now this next one is 34 over 2. Well, 34 over 2 is the whole number 17. Okay? So when you multiply, only the top number, the numerator, is affected here, right? So 10 over 4, y, minus 34 over 2. And then those reduce. If you want, you can use your button. 2 times 5 over 4 is, that's the mixed fraction. There's the 5 over 2. Don't forget to put the y on it. That's a common mistake. Don't forget, after using the button, that there's still a y on it. Okay, and then you can do 2 times 17 over 2 as well if you need to. Okay, and again, if you hate that, you could do the whole thing in decimals. This would have been 1.25. And this, I guess, is 8.5. So you could do decimals as well. All right, now we're collecting like terms. So the two terms containing y are staying on the left side. This is the one term moving to the other side, so it will be plus 17, like that. And now we simply figure out how many y's we have. 5 halves minus 3. That's how many y's we have. 5 halves minus 3 of them. So that's 5 halves minus 6 halves, or negative 1 half y. Again, you could do it this way. 5 halves minus 3 is negative 1 half y. On the right side, you can simply do negative 22 plus 17, and you will get negative 5. So y is negative 5 divided by negative 1 half, or 10. Right? You could do that here too. Negative 5 divided by negative 1 over 2 is 10. So now we know that y is 10. Okay, once you have y equals 10, you can substitute it here to figure out x, or here to figure out x, or remember, I usually go to this one since x is already isolated. So I'll go to that one again here. So x is 5/4 times, this means times, multiplication implied, 5/4 times 10 minus 17 halves. And this is 50 over 4, or 25 over 2, minus 17 over 2, which is 8 over 2, or 4. Okay, or you could do it here. 5 over 4 times 10 is that, minus 17 over 2 is 4. Okay? And there you go. Now you have your answer. Write it as an ordered pair because remember, it does represent the point of intersection of the two straight lines. Okay, so I hope you're starting to see that each problem will follow the same steps. First, isolate x or y from either equation. Substitute its expression into the other equation. And then hopefully follow out the steps that should appear natural to you or logical. Eliminate the bracket, collect the like terms, solve. Okay, we did this one last day, so this is the elimination note from last day. We got the same answer, of course. This brings up a question that I'm sure you're wondering. You may be wondering, can I just learn one of the methods and solve the whole test using one of the methods only? And as you might imagine, the answer is no. So the test is going to ask you, solve one of the questions graphically, solve a different question using elimination, solve the next question using substitution, and so on. So you do need to know all of the methods, okay? Okay, let's do 1/3 example using substitution, and this is the P's and Q's example. Okay, so let's go ahead and try this one. This is how it appeared in the beginning. Now, for substitution, remember, first you begin by isolating one of the variables. Now, if you were going to do decimals, you would therefore isolate either P here or Q here, because dividing by 5 or dividing by 4 would give you nice numbers. Okay, if you're going to use fractions, you could even isolate the p here simply by dividing these by 17. Okay, but you would not isolate p here if you were going to use decimals. So I guess I will take the first equation and I'm going to isolate p over here. All right, so from the first equation, I'm going to isolate the p. That way, if you're at home doing it in decimals, you can compare it. So it would look like this. 5p is. Now, both of these have to go to the other side of the equation. Okay, because I'm trying to isolate p. So when this goes to the other side of the equation, it'll be negative 4q. When this goes to the other side of the equation, it'll be positive 14. So negative 4q plus 14. So that step is really important. If you have one of those signs incorrect, nothing will work beyond that. So be very careful. Okay, now we divide by 5. So if I'm going to use fractions, that would just look like this. All right, if you wanted to use decimals, you'd have negative 0.8 here, and I guess 2.8 here. Okay, so I'm done. I now have an expression for p, so I put it in the other equation where the p is. So this binomial is going right here. So 17 bracket. All right, and now I carry out the steps again, which I hope by now look logical to you. So first, open this up. Only the top number is going to be affected, right? So 17 times negative 4/5, that's going to be negative 68/5 times q plus, okay, I don't even know what 17 times 14 is. So I'm going to use the calculator. 17 times 14 over 5 is that or that. 238 over 5. Okay, so 17 times 14 is 238. 17 times negative 4 was negative 68. Okay, so all we did was open the brackets. And what happens next? This is now when we collect like terms. So we have 2 terms containing q and 2 terms that do not. So I'm going to make the q terms go to the left side. So this one's already on the left. When this one comes left, of course, it's subtracted. On the right side, we already have 31. This term has to join it, so it will be subtracted. Okay, so 2 terms moved in that step. Okay? So this step went to the right, this step went to the left. And now I have to figure out how many q's I have. So you could do it by getting a common denominator. This is negative 68 over 5. This would be negative 15 over 5. So you can do it that way, or you can use a calculator. Negative 68 over 5 minus 3 is, that's the mixed fraction. This is the improper fraction equivalent. Negative 83 over 5. Okay, that's the left side done. And then you would do the same thing for the right side. So if you want to get a common denominator, this is 31 over 5. You could make it 155 over 5. Okay, or you can use the calculator. 31 minus 238 over 5 is negative 16 3/5 or negative 83/5. Like that. So how is Q determined? By dividing negative 83 fifths by negative 83 fifths. And that will, of course, give you 1. All right, once we have Q, you can substitute it here or here. I'm going to go to this one right here since P is already isolated. This is negative 4 fifths multiplied by Q. So negative 4 fifths multiplied by 1 plus 14 fifths. So that's negative 4 fifths plus 14 fifths, which will be 10 fifths or 2. Okay? And that's it. At that point in time, make sure you write the value of P first, then the value of Q. We use the order of the alphabet, so P before Q. All right, so this second method, well, I guess it's a third method actually. It's the second algebraic method. It involves quite a few steps. So please take the time to practice this method. I've assigned the very same questions that you tried using elimination. So you're going to revisit those same problems and you're going to try to solve them with this method of substitution. Okay, thanks very much. Have a great day.